So thank you for the invited to me here. I'm very honored to be here presenting. So I'm Shuichi Ihara, the principal engineer at DDN. So today I want to talk about what we are providing. So for the AI infrastructure. So I can go through my presentation. So maybe you not much familiar with the DDN. So who we are. Let me introduce a little bit the DDN overall. So the company, the DDN, founded 1998. That was almost 27 years ago back. So our business, the more storage providing for the high performance computing, the supercomputer in the world. So the many of supercomputer in the world, the large institute or research center or university, they selected the DDN storage system for their supercomputer. So we are the market leader for the data industry. Then after the 10 years, supercomputer market moving forward, the enterprise market, which means that the company built the supercomputer themselves. So also the company that selected the DDN or to build the supercomputer themselves. So we are very successful at that market for providing the storage. Then after the few years, then last 5 years, so AI boom that became, right? So we are easy to adapt from HPC to the AI market, because when you look at the AI infrastructure, so that we had a presentation today, it's a very similar architecture to what we've done over the 2 decades. So for example, a lot of the compute nodes, a lot of the high-speed network to connect the compute to the storage, and the massive data come from the compute to the storage. So still the AI infrastructure, so they really need the high-speed network, high-speed storage. So the massive data come from the storage, also that come from the compute. So that's why the DDN adapted to the HPC to AI, and now we are the market leader both on the HPC and the AI today. So we have a lot of customer, not only academic, but a lot of the industry customer. So automobile, financing, etc. So a lot of the company is using the DDN storage system. Then more than 500,000 the GPU is running on the top of the the DDN storage system in the world today. So one that I wanted to mention here, so NVIDIA is also a great partner with us, but they're also one of our customers. So they selected the DDN storage system in 2017, and they use DDN storage system for the supercomputer at their lab. So they are continuing to use the DDN. So they're so the NVIDIA is the one of our great customer, not only just a partner. Just I wanted to mention here. Not only the industry, so we have a great partner for cloud partner. We have a lot of the cloud partners. So that who also use the DDN storage system for their cloud infrastructure to build GPU as a services. Of course, there are a lot of the different requirements for cloud to build the cloud infrastructure. But we provided a lot of capability to accelerate their business as the cloud. So I can show the more the detail in the later. So what we are providing the product to the customer. So we have 2 major products. One is Exascaler, the version 6. We call it the Exa 6. Which is the DDN, the parallel file system solution for AI or the HPC infrastructure. So it's a massive scale. It's a massive scale. And so it's running on the top of the Lustre file system, which is an open source parallel file system. Lustre has more than 20 years history. So the performance is predictable. But we are not only shipping the Lustre to the customer. So we added the number of enterprise capability on top of the Lustre. Then, like the simplified management, the simplified deployment, a lot of the performance optimization for AI, so the security capability, so on. Actually, so the Exascaler is the DDN, the branded, the Lustre distribution for AI on the HPC. So the another product, the DDN INFINIA, which is a brand new, so the next generation of the object storage for AI on the HPC in the future. So we spent over the 7 years to build this software. It's a massive scale of the key value stored object storage. So the AI infrastructure probably the more the complex in the future. So training is okay, but in the future it's a more complex configuration. So the people really want to simplify the storage system. So the INFINIA that's the address that's the problem. So we right now, so we have the product, the Exascaler, the INFINIA, then 2 engine to provide to the nice storage infrastructure for AI on the HPC from DDN. Let me go through the more detail on the both of the product. So INFINIA, as I said, this is a pure software-defined storage. So you can deploy on the INFINIA on cloud. You can also deploy on the on-premise. So maybe you can deploy on the both together in the future. So it's totally the software-defined storage. So any type of the data, the structured, unstructured, the semi-structured, wherever so you want, so you can store the data into the our key value store, the INFINIA. So it's a massive scale. So we have the few number of customer today. They are using the one of the customers is using the INFINIA with 1 exabyte. So it's really the scaling it's supported the massive scale. Then unlimited the metadata information. So also one of the key capability of the INFINIA is a super low latency to store the data or the loading the data. So object storage in general, so you can look at the object storage, so the data store over the internet, or maybe it's archiving, right? So it's a more high latency, but it's it's a more reliable, or it's a support over the internet like that. But the INFINIA, we can replace the existing object storage with INFINIA, but we are not much want to do that, because INFINIA does support super low latency, but which never can do that. So we want to slowly adapting the INFINIA to the existing the product, but we really need to find the light location, the light area. So we really want to put the INFINIA with the light configuration. So that's the INFINIA is going to do in the future. So we do the support the INFINIA, the S3, then we do support the block device on top of that. So the file service or the SQL is coming at the end of this year. So we have a lot of the protocol on top of the key value store of the INFINIA. So Exascaler, so this is as I said earlier, it's a kind of enterprise version of the Lustre file system. So why the Lustre? So the Lustre is open source, and again, so they have over the 20 years history. So a lot of cloud vendor like Google, Amazon, the Microsoft Azure, everybody they're using the Lustre file system for build their managed Lustre services. So now the Lustre is more getting the popular for AI on the cloud. So we have a lot of the DDN. We have a lot of developer of the Lustre, and still 60% or the 70% of the code of the Lustre file system from the DDN. So we know the Lustre we know we adding the new capability or the new feature for the raster file system from the DDN. So that's why we selected the raster file system, the core engine of the Exascaler. On top of that, we implemented the number of the capability for raster. Some of the capability or some of the feature is already merged into the upstream raster. So for example, the GPU direct storage. So this is the our first implementation of the GPU direct storage with the NVIDIA. That was the 2017. Then after that, the storage vendors that implemented the similar, but we implemented the GPU direct storage the first. The other capability, we also implemented the automated caching on the GPU or the compute node. When you read the data from the Exascaler, so data can be cached on the GPU node. And when you read the data again, so the data come from the cache, not from the the Exascaler itself. So you can eliminate all the network traffic for the second read, so that you can reduce the latency to read the data. The GPU nodes, typically they have the number of network adapter, like 2 adapter or the 4 adapter, or sometimes 8 adapter for storage. So you can use all of the network adapter together to aggregate making the maximum of the bandwidth to the storage. So that's also the support multi-rail network configuration with the Exascaler. We also support the Docker container. I can describe more detail in the future later. But we do providing the CSI driver for Exascaler for Kubernetes. Then we also support the multi-tenancy. This is also very important capability for the cloud infrastructure. We also support the multi-protocol access, which means you can access the Exascaler data through the Exascaler client. I mean the raster client. Also, you can access the data through the S3 or the NFS or the SMB. So it's still the same single namespace, but you can access the data from any protocol. So that's kind of the future. So we added. Then so we are shipping as an Exascaler to the customer. So we are not only just shipping the software, but we are attach on the Exascaler on top of the hardware, then making the single appliance. So the AI 400X3, which is third generation of AI 400X. So this is just a 2U box. Then just 24 drives installed in front. Then I didn't mention here, but you can get the 100 gigabyte per sec for write performance, then 130 gigabyte per sec read performance, just only the 2U box. So you can build the 1 petabyte the flash system, just a 2U box. So up to the how many, which the drive you want. But the box itself doesn't support up to the 1 petabyte. Then we also support the latest network, the interface, the 400G, the Ethernet or the InfiniBand. We do also support the Bluefield from the NVIDIA. So we have the number of the options. So it depends on what you want. So this is also the part of the we already verified by NVIDIA for as a reference architecture for NCP or the SuperPort. So we have it's already the customer. We are shipping this product to NVIDIA, the new Blackwell system. Yeah, so I mentioned earlier. So NVIDIA is one of our customer of. Then they built their supercomputer with our storage. They have the number of supercomputer series from the Selene and the first supercomputer they built. Then the next one, the EOS. Then upcoming the Blackwell the supercomputers are coming. So all of them, so that they use the DDN storage system for fast layer of fast layer of the file system. So the reason why, so our system is it's already the proven the performance, it's predictable. So in here, so you can see here, so this is just a 6 AI 400X3 box. Then so this is a real the benchmark that we tested at the NVIDIA. So you can, so when we started the DGX the GB200, so we got the 80 gigabyte per sec from one box. Then when you increase the number of the box, so eventually you can get around 600 gigabyte per sec write. So it's a linear scaling, so which means that you can keep the GPU busy. Then you can also get the good the checkpoint the write to the disk. So this is it's already proven than the predicted on the system. So we are storage vendor, but we are not only just selling the product. So we are doing a lot of the research. We are investigating a lot of the performance optimization or evaluation or AI workload. So this is one of the example. So AI training. So AI training is a very data intensive. So when you before the training, so you need to ingest the data to the storage system. The before the training, then after that, you need to some the preparation or the preparation before the training. But before the training, so eventually, so data have to be loaded on the GPU memory, or the model also that need to be loaded on the GPU memory. But after that, no much the read, because of the there's a lot of the parallelization is there, the data parallelization, the model parallelization. So all of the data. So once the data is loaded to the GPU model, GPU memory, so no much the read that happen after training the start. After the training the start, so you see the more the light operation to the disk, because so the training takes a very long time. So that sometimes 1 month or the 2 months. So the longest one is maybe the 6 months. Do you believe the training over the 6 months without no failure, without a failure? Its answer is not. So that there are a lot of hardware failure or the software failure or the network failure during the training. So meaning you really want to restart for latest to the good state, not go back from the scratch. It's a very waste of the time. So the checkpoint to the help to the keeping the last state, GPU memory the state, then you can go back to the the last one, then restart the training again. So meaning you really want to keep the checkpoints every hour or 30 minutes. So if the system allows, so you have to do the checkpoint as much as possible. So that's the training is a more the light intensive workload rather than a read intensive workload. So that's we figured out. So this is we tested in the lab. So this is just testing of the GPT-3, the training on the Megatron LM. You can see here when the checkpoint is running, so the GPU is idle. So you have to minimize the checkpoint time. Otherwise, you are losing the GPU time as well. So this is what we we are investigating over IO optimization for the training. So the inference. So this is also the interesting area. So we are investing into right now. So we are a lot of the benchmarking inferences, but the inference is more the complex on the training. So because of the people really wanted the fast response, but a lot of the different parts have to be involved, like network or the network routing. Also the service also involved. there are a lot of the stuff for the inferences. So we started the benchmarking. So for the storage perspective, so LM cache, the KB cache, is one of great idea to improve the inference performance. So we tested. So we are evaluating. So KB cache, LM cache with the inferences. So actually, we tested, and they have the benchmark suite, the LM bench. However, when we tested the LM bench, there's a we found that it's good, but we found that it's not enough to simulate a real use case of the inferences. And so we added the benchmark method, the benchmark attribute for the benchmark tool. And so we contributed to the benchmark tool for LM cache or the LM benchmark, and the community accepted. So now, we can show the more the realistic the benchmark, realistic the workload of inference with our benchmark tool. So if you are interested in that benchmark, so you can have a look at the LM bench on the repository. I mean the upstream. Let's see. So go back to the Exascaler. So as I said earlier, so we do the support the CSI driver for Exascaler for Kubernetes. So not only the Kubernetes but also OpenShift. So it's very unique the CSI driver, extremely high performance. We do the support the various configuration, like zoning. So if we have the different Kubernetes cluster with a different location, we do the support that such kind of configuration as well. So we also added the number of the Exascaler unique capability on top of the into the CSI driver. So that's the we are so you can download the the CSI driver, the GitHub, the DDN, the GitHub. But so I can show you the number of capability, number of the result here. So we tested the IO 500, which is very standard benchmark tool for HPC, but also the became for AI. So it's a published benchmark tool. So it's the same idea of the top 500. So when you are interested in the benchmark, so you can submit the result. You can submit your result. Then so the community, so you can see on the list. But so many of IO 500 tests, it's running on the bare metal, not the Kubernetes. But we implemented IO 500 tests on the Kubernetes with the CSI driver. Then so you can run the IO 500 on the Kubernetes today. Then we compare to the IO 500 result with the bare metal on the Kubernetes with our Exascaler driver. So this is a graph on the right side. Blue bar is bare metal. The orange bar is Kubernetes with the CSI driver. So you got the good performance. Then it's almost same performance of the both of them. So meaning the no overhead, no performance degradation in our driver. So you can get the maximum of the performance with our driver. No time. Okay. So moving forward, so we started the collaboration, the SKT, 6 months ago back, because of that we have a good capability on the CSI driver. So we have storage platform for AI. So SKT offer for us, the GPU, the network virtualization with the Petasas, Gian presented earlier. So we have the good lab in Tokyo. So we have a more than 100 server in the lab, GPU node, the storage. Then so SKT offer the software. Then we integrated together to work on the DDN solution into the Petasas cloud. So we run the number of the joint benchmarking or the evaluation with that. So this is the Gian mentioned earlier. So I can just skip. Yeah, so we had so this is a benchmark configuration. We had one GPU node with NVIDIA. The another one is AMD, MY300. So this is the two server, but it's a very powerful the GPU server with the petasas. So we tested the I/O benchmarking with that configuration. So this is also the Jian presented on his presentation. So we got the good performance of the native Exascaler. So we got almost 98% of the performance of the network bandwidth, theoretical network bandwidth from the virtual machine. So this is really the good. Then also the another benchmark. So we run. This is the benchmark through the BAT I/O from the QEMU. So not native of the raster file system, but still the overhead in the middle on the BAT I/O. So read performance is almost good. We are getting the 90% of the performance of the bandwidth, but write performance is a little bit lower, so 75%. So we are now investigating more, hopefully, so we can get the more better performance in the future. But it's overall, so the performance is really good with the storage infrastructure, the CSI driver, and the petasas that provided the virtual machine. So conclusion, DDN is a storage vendor, but it's not just a storage vendor. So we are the more, you can think about the strategic partner to build your AI infrastructure for scale. So we have the two products, the Exascaler and the INFINIA. So it's coming the next generation the product. So we have a strong field engineering. So we have a great, very strong engineering resource in Korea as well. So it's not only the people know the only storage, but also they know the end-to-end solution. So we continue to work with SK Telecom. So thank you for this opportunity. So we are really happy about working with them to build the next type of AI infrastructure with virtualization and petasas. Thank you very much. So first question, yeah. So I think that now more the raster became a file system for AI because of the a lot of the cloud vendors that contributed to the raster file system today. Then eventually the user use on the cloud infrastructure. They don't care about what file system behind, but eventually they're using their application on the top of the raster file system. So I think we are there are a lot of the discussion on the lot of the discussion on the raster community to address the AI the workloads, the problem or the challenge. Because of we've already done a lot of the performance improvement for AI workload. Then also we added the new type of the capability which we never implemented for HPC, but it's more important for the AI, for like security or segregation, the isolation, the multi-tenancy. So we are a lot of that we are implementing that kind of the capability right now. So that is one thing, yeah. There's no open source INFINIA core engine. Sorry about that. However, so we have a SDK. So every services of the INFINIA implemented on top of the SDK. So we can provide the SDK for user. So you can implement it or you can adapt your application with the INFINIA using the SDK. So that's possible. So I think we want to more work with another vendor to making the good ecosystem with the INFINIA. So we just started, but you yourself, so you can implement your application with INFINIA SDK.
박수 부탁드리겠습니다.